Hello children, welcome to 7th Science online classes. Chapter 13 Motion and Time. So in the last classes we learned motion, speed that is distance upon time, average speed that is total distance covered by total time taken, uniform motion and non-uniform motion with examples. And today we are going to learn measurement of time. Measurement of time. Time waits for none, right? But how do you know that? Nowadays, we use clocks or watches for knowing the time. But if you did not have a clock, how would you decide what time of the day? Have you ever wondered how our ancestors could tell the approximate time of the day by just looking at shadows? Our ancestors noticed that many events in nature that repeat after a time interval. Some examples. They found that the sun rises every day. So the rising of the sun they considered as morning time. The time between the sunrise and sunset, that is the daytime. And the time between one sunrise and the next was called a day. Similarly, a month, the time between two new moons. And year, the time the earth takes to complete its one revolution around the sun, that is called year. So from by looking these natural events, we cannot tell the accurate time. But nowadays, we get accurate time by using some devices, time measuring devices or clocks. Clocks use the concept of periodic motion to measure time. So you know that clocks have some hands, minute hand, second hand, hour hand. So these hands are moving in a periodic way. So that periodic motion that helps us to find the time. It means that it uses motion that repeats itself in equal amounts of time. So you know that 1 minute means 60 seconds. So 2 minutes means 120 seconds, like that. 1 hour means 60 minutes. So that is they repeats itself in equal amounts of time. There are different types of time measuring devices. We will see such devices. Different types of time measuring devices. So here you can see some time measuring devices that our ancestors used in their time. See, first one is the sundial, second is water clock, third this is sand clock, and this you may seen this pendulum clock. So this pendulum, it is moving like this, and this is a quartz clock. So no need to study these names. I'll just show some devices we were used that time. And this quartz clock, nowadays we are using quartz clock and pendulum clock also. Yes children, now you saw the pendulum of a pendulum clock. And have you seen that movement? It moves this both directions. So we will see the periodic motion of a simple pendulum. And the working of clocks is rather complex, but all of them make use of some periodic motion and one of the most well-known periodic motion is that a simple pendulum. So we have to study the motion of or the periodic motion of a simple pendulum. So we can also construct one simple pendulum by this. Okay, so here one metallic ball is here. That metallic ball is called bob. A simple pendulum contains a bob. It is a metallic ball or a stone which is suspended from a rigid stand with the help of a thread. So we can also make such a simple pendulum. Take one metal ball or a stone and tie with a long thread and attached or fix this thread in a rigid stand. Okay, and when it is not moving, we can call it that simple pendulum is at a rest position. So rest position means it is not moving. But when we hold one side, when we hold this metallic ball or this bob and raise here and just drop it or release this, it start to or it begins to move from one side to other side. Okay, and that kind of motion or that kind of to and fro motion, to and fro, that is from here to here, from here to here, that motion is called to and fro motion. So that to and fro motion of the pendulum is called oscillatory motion. So what is oscillatory motion? The to and fro motion of the pendulum is called oscillatory motion. And when it is at a rest position, that this is the rest position, so that we can call that pendulum is in the center, or we can tell that pendulum in mean position. So just see that words. Mean position means that the center position. When the pendulum is at a rest position, yes, it was here. Yes, mean position, that is the center. And when we release the bob, it start to move. We already said that is a to and fro motion. So from the mean position, see, the pendulum does move from the mean position of to its extreme position on other side. See, from the center to this extreme position. Again it come to this mean position, then go to another extreme position, the same level. Okay, so I'm just showing once again. From the mean position, first go here, then come back, again go here, the same height. Okay, so that is called the to and fro motion of simple pendulum. Hope you got that concept. Okay, so periodic motion of a simple pendulum that we are studying. So oscillatory motion means the to and fro motion of the pendulum is called as oscillatory motion. The bob of the pendulum does move from the center or mean position. So see that word, mean position means that center of the pendulum to its extreme positions on the other side. Got it, children? Oscillatory motion is the to and fro motion of the pendulum. Then we will see what is oscillation. When the bob moves from its center, that is from mean position, to its extreme ends, it is said to complete one oscillation. So one oscillation means the bob moves from mean position to its extreme ends. First you watch this video. See, this is a simple pendulum, and when we release that pendulum, it starts to move from the mean position to extreme ends. So that is called oscillation. So we can just calculate or find the oscillation by looking two ways. First one is just to see in this picture also, that is a bob starting from its mean position O. So just to see, watch that, see that picture. Okay, children, mean position O moves to A, to B, and back to O. Got it? First from mean position O, then go to A, come back to B through this O, then again reach O. That is called one oscillation. Or we can tell that the pendulum completes one oscillation when its bob moves from one extreme position A to the other extreme position B and come back to A. That is also one oscillation. So I am repeating once again that two ways once again what is oscillation. First start from O. The bob is start from O, that is mean position, moves to A to B. Can you see B? From A to B, then come back to O. That is the oscillation, one oscillation. Or we can tell that from the extreme position A to B, then again come back to A. That is also one oscillation. See once again, watch the video. See. Start from mean position, one extreme right side, then left side, then come back to O or mean position, that is one oscillation, or one extreme right position to left, then come back to right, that is also one oscillation. See, then what is time period of a pendulum? The time taken by the pendulum bob to complete one oscillation is called its time period. So by calculating the time period, we need a clock, a stopwatch. Okay, in this video you can see that one stopwatch is there. So the time period of a pendulum means the time taken by the pendulum to complete one oscillation. Okay, that is called time period. So here today we studied, first you studied oscillatory motion. What is oscillatory motion? Oscillatory motion means the to and fro motion of the pendulum is called oscillatory motion. And oscillation, what is oscillation? The bob moves from its mean position or the center to its extreme positions. That is called one oscillation. And time period of a pendulum, the time taken by the pendulum to complete one oscillation. That is called time period. Okay, children. So you just read that textbook. But the important thing is you have to, no need to memorize. Memorize means you have first you understand the thing, then you have to study that this definitions of what is oscillatory motion, what is oscillation, time period. Okay, if you by heart means first before by hearting, first you understand the thing, then by heart that definitions. Okay. Okay, children. Thank you. All the best.